Good morning everyone, I am AGM. Today we will start second video. So chapter 1 chemical reaction and equations. So we read yesterday up to magnesium. So today we will start the balanced chemical equation. 1.1.2 balanced chemical equation. Recall the law of conservation of mass that you studied in class ninth. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Is the chemical equation 1.2 balanced? Let us learn about balancing a chemical equation step by step. The word equation for activity 1.3 may be represented as zinc plus sulfuric acid gives rise to zinc sulfate plus hydrogen. The above word equation may be represented by the following chemical equation: Zn plus H2SO4 arrow mark ZnSO4 plus S2 means Zn plus H2SO4 gives rise to ZnSO4 plus H2. Let us examine the number of atoms of different elements on both sides of arrow. Element zinc, number of atoms in the reactants LHS is 1. Number of atoms in products RHS is 1. Now element hydrogen, number of atoms in reactants LHS is 2. Number of atoms in products RHS is also 2. Element Es, number of atoms in reactant LHS is 1. Number of atoms in products RHS is 1. Element O, oxygen, number of atoms in reactants LHS is 4. Number of atoms in product RHS is 4. As number of atoms of each element is same on both the sides of the arrow, equation 1.3 is balanced chemical equation. Let us try to balance the following chemical equation. Fe plus H2O gives rise to Fe3O4 plus H2 1.4. So step 1, to balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Fe under the box plus H2O under the box gives rise to Fe3O4 under the box plus H2, that is 1.5. Step 2. List the number of atoms of different elements present in the unbalanced equation. Unbalanced equation 1.5. Element Fe. Number of atoms in reactants LHS is 1. Number of atoms in product RHS is 3. Next element is H, hydrogen. Number of atoms in reactants LHS is 2. Number of atoms in products RHS is also 2. Element is oxygen. Number of atoms in reactants LHS is 1. Number of atoms in the product RHS is 4. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be reactants or a product. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS. The balance the oxygen atoms. Atoms of oxygen initial in reactants 1 in H2O, in product 4 in Fe3O4. Second, to balance atoms of oxygen, second one to balance in reactants 1 into 4, in the product 4. To equalize the number of atoms, It must be remembered that we cannot alter the formulae of a compounds or elements involved in the reactions. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2O and not H2O4 or H2O4 or H2O bracket 4. Now the partly balanced equation becomes Fe plus 4H2O gives rise to Fe3O4 plus H2 1.6 partly balanced. Step 4. Fe and H atoms are still not balanced. Pick any of these elements to produce further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of H atoms, make the number of molecules of hydrogen as 4 on the RHS. Atoms of hydrogen 1 initially 8 in 4H2O, in product 2 in H2. To balance atoms of hydrogen, second one to balance in reactants 8, in products 2 into 4. The equation would be Fe plus 4H2O gives rise to Fe3O4 plus 4H2, that is 1.7 partly balanced equation. Step 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. Atom of iron 1 initially, in reactants 1 in Fe, in products 3 in Fe3O4. Atoms of iron, second one to balance, in reactants 1 into 3, in product column is 3. To equalize Fe, we take 3 atoms of Fe on the LHS. 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2, that is 1.8. Step 6. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2, 1.9 balanced equation. The number of elements on both sides of equation 1.9 are equal. This equation is now balanced. This method of balancing chemical equation is called hit and trial method, as we make trials to balance the equation by using smallest whole number coefficient. Step 7. Writing symbols of physical states. Carefully examine the above balanced equation 1.9. Does this equation tell us anything about the physical state of each reactants and product? Now, no information has been given in this equation about their physical states. To make a chemical equation more informative, the physical states of the reactants and product are mentioned along with the chemical formulae. The gases, liquids, aqueous, and solid state of the reactants and products are represented by the notations G for gas, L for liquid, AQ for aqueous, and S for solid, respectively. The word aqueous is written if the reactant or a product is present as a solution in water. The balanced equation 1.9 becomes 3Fe S in solid plus 4H2O in the bracket G, that is gas, gives rise to Fe3O4 in the bracket S means solid plus 4H2 in the bracket G as a gas, that is 1.10. Note that the symbol G is used with H2O to indicate that in this reaction water used in the form of steam. Usually, physical states are not included in chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow in the equation. For example, CO in the bracket G plus 2H2 in the bracket G gives rise to, on the arrow mark 340 atm means atmospheric pressure, gives rise to CH3OH in the bracket EL means liquid, that is 1.11. 6CO2 AQ in the bracket means aqueous plus 12H2O in the bracket EL means liquid, gives rise to, on the arrow mark sunlight, and below the arrow mark will be chlorophyll, gives rise to C6H12O6 aqueous, that is glucose, plus 6O2, that is aqueous, plus 6H2O, that is EL means liquid, 1.12. Using these steps, can you balance equation 1.2 given in the text earlier? Now questions. Why should a magnesium ribbon be cleaned before burning in air? Second question, write the balanced equation for the following chemical reactions. First one, hydrogen plus chlorine gives rise to hydrogen chloride. Second one, barium chloride plus aluminum sulfate gives rise to barium sulfate plus aluminum chloride. Third one, sodium plus water gives rise to sodium hydroxide plus hydrogen. Third question, write a balanced chemical equation with the state symbols for the following reactions. First one, solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of the sodium chloride. Second one, sodium hydroxide solution in water reacts with the hydrochloric acid solution in water to produce sodium chloride solution and water. So we'll stop this video here. Please subscribe and share. Support me. Please subscribe. This is my videos for reading purpose. Those who are not capable to read as a lazy persons, you can listen this video as I'm reading this 10th standard science line by line, so it will be very helpful for you. Please subscribe as many as possible and share. Support me, like, comment. एजम दरा जनहित में जारी नमस्कार.